Hello. We are on, whoop, don't know how to get rid of that thing. We are on 7.05 for pre-calc today, and we're going to be talking about more matrices. So exciting. This is the big ones that we're talking about today. So we're going to focus our attention on using Gauss-Jordan elimination for these problems, and that means we are putting them in reduced row echelon form. Put in reduced row echelon form. I'm going to warn you, these are long, and it's very easy to make one mistake that can throw you off for the whole thing. So really important to be really careful, double check your math, keep it neat so that you can go back and find any mistakes that you might have. So these are still our 3 variable system of equations. So last time we looked at just the 2 variables. And today we're going to do 3 variables. Minus 5y plus 5z equals 17. All right, so this is just kind of our streamlined way of solving a system of equations, and I'll show you also after we do this one how to input this into your calculator. All right, so first we want to set up our matrix. So we're going to take just the coefficients and write those out. So I've got 1, -2, 3, draw my line for like my equal sign is 9, -1, 3, 1, -2 for my second equation, and 2, -5, 5, 17 for my third equation. All right, so what you guys want to focus on, and I'm going to make a list of steps over here, is really focus on number 1, always getting your lead 1. And you're going to work column by column. Number 2, you need to get zeros above and below that lead 1. And then repeat for the next column. So you're going column by column for next column. A couple little things to remember here. Always multiply the row with the lead 1. When you're trying to multiply and then add to get rid of, to make something into a 0. So when adding to another row. Adding to another row. And of course, check these on your calculator. I don't want them done on your calculator. I want them checked on your calculator, unless it says to do it completely in your calculator. So really, really important, your 3 steps, and working column by column here. Made that a little too long. All right, so first I'm going to start by going down. So my first matrix is, again, I'm looking at column 1. So first of all, I see that I already have a lead 1. Now, if one of the other rows had a 1 there, you could always switch the rows to start off with a lead 1. Okay, so now that we already have our lead 1, that's step number 1. Step 2 is to get zeros above or below. Well, there's nothing above it, so we just need to get zeros below it. So we need to get both of those to become zeros. Now, as you get more comfortable, you could get the zeros all in the same step. But for today, on this first one, I'm going to, at least in this first time, I'm going to start by doing just one thing at a time. So I'm going to focus on getting this -1 to become a 0. So to get that to become a 0, I always am going to multiply my row with the lead 1 in it. So now, in order to get -1 to be a 0, I just need to add it to a +1. Well, good news. I already have a +1 in row 1. So all I need to do, and remember, label on the new matrix, is I'm going to take row 1 and add it to row 2. Or you can think about it as 1 times row 1 plus row 2. Okay, so the first row is going to stay the same. I'm going to rewrite that. And my third row is going to stay the same. So 2, -5, 5, 17. So the only one that's changing is this middle row. So to do that, and I usually like to use my fingers, which I can't show you here, but I would hold my finger here and then 1 on here and say to myself, okay, 1 times 1 is 1, minus 1 is 0. Then I go to the next one. 1 times -2 is -2, plus 3 is 1. 1 times 3 is 3, plus 1 is 4, and 1 times 9 is 9, minus 2 is 7. Okay, so again, I'm working on one column at a time. So I'm first working on this column. I've got my lead 1, and now I have a 0 below it. Now I need to get this 2 to become a 0. I don't worry about anything else until I finish that first column with getting a 1 with all zeros below it. So to get this 2 to become a 0, again, look to your lead 1. First of all, what do I need to add to 2 to get it to become a 0? Well, I need a -2, the additive inverse. -2 plus 2 will give me 0. So go up to your lead 1. It's always a 1 if it's a lead 1. So now you say, well, I need this to become a -2, so I'm going to multiply row 1 by -2 and add it to row 3. So row 1 and row 2 are going to stay as is. We already got those set. Now for row 3, again, I'm going to take -2 times row 1 and add that to row 3. And I label it when I'm doing it on my new matrix. So again, I kind of guide myself with my fingers here, and I'll say -2 times 1 is -2, plus 2 is 0. I'll put this row in pink because this is the one that's changing. -2 times -2 is 4. Minus 5 would give you -1. -2 times 3 is -6, plus 5 is -1, and -2 times 9 is -18, plus 17 is -1. Okay, so now we are done with column 1. We've got a lead 1 and zeros below it. Now we're going to focus on column 2. So for column 2, we need to get that to have a lead 1. So our lead 1 needs to be that staircase of 1s right here. Well, good news. We already have our lead 1. So that's a check mark. So now I need to get zeros above and below my lead 1. If that had not been a 1, that's when you would multiply by the reciprocal to get that. And we'll look at that in our last row. We'll have to. All right, so now we're just focused on getting this -2 to become a 0, and then we're going to get the -1 to become a 0. So first, let's do the -2. All right, so we always multiply the row with the lead 1 in it. So again, you're only looking at the column right now. We finished the first column. We're on to column 2. So we have our lead 1. We want this -2 to become a 0. So to get that to become a 0, I need to add it to a +2. So I look to my 1 that is in this column, and that is row 2. So I'm going to multiply row 2 by +2 and add it to row 1 to get that to become a 0. So I label it on the row that's going to be changing on the new matrix. So that's going to be, sorry about that. So I think that I was saying here that we had to get this -2 to become a 0. So we want to multiply the row with the lead 1 by the additive inverse. So label it on the row that's changing. So we'll make this -2 times row 2 plus row 1. And that's what's going to change. Everything else is going to stay the same. So I'm going to keep that in blue here. So 0, 1, 4, 7. Row 2 stays the same, and row 3 stays the same. Okay, so now back to row 1. So again, use your fingers to guide you through it. So the reason you must use this process that I'm saying, and this exact process that I'm saying, is because if you don't, you're going to mess up all the work that you already did. So that's why we do it the way we do it. So here, when I do -2 times row 2, it's -2 times 0, which is 0, plus 1 will leave me with a 1 still. So if you do it in this way, your lead ones will stay lead ones that you've already done, and your zeros will stay zeros. It won't mess up any of the work you did in column 1. All right, so now I'm doing -2 times 1, -2 minus, oh, wait a minute, we need to do +2 there. And that's why we do it out like that, to catch ourselves. So we want to do 2 times 1 minus 2 would give us 0. All right, pause the video here and see if you can finish out that first row on your own. Okay, so here you should have gotten 11 and 23 for that. Okay, so doing 2 times the row 2 plus what you had in row 1. So 2 times 4 plus 3, 2 times 7 plus 9. All right, so now we have our first column is already done. Second column is what we're working on right here. We've got our lead 1 and a staircase of 1s, and then we have a 0 above it. Now we need to get a 0 below it. So my goal right now is I need to make this a 0. So how do I get that to be a 0? Well, anytime we're trying to get zeros, that's when you're going to multiply the lead 1 row by the additive inverse and add it to the row you're trying to change. The only time you're going to multiply a row by something is when you're trying to get a lead 1. Okay, so we want to get a 0, so we're going to look to our row with the lead 1, which is our second row, and say, okay, well, the additive inverse of -1 is 1. Good news, row 2 is already a 1, so I'm just multiplying row 2 by 1 and then adding it to row 3. So really I'm just adding those 2 rows together. All right, and the first 2 rows are going to stay as is. So we've got here 1, 0, 11, and 23, 0, 1, 4, 7, and now let's do the last row. So pause your video and see if you can add those 2 rows together. All right, so again, it shouldn't mess anything up with our zeros here. So 0 times 1 is 0, plus 0 is 0. 1 minus 1 is 0, 4 minus 1. Okay, so now first column, done. Second column, done. Now we've got to worry about our third column. So the third column is, first thing we need to do is get our lead 1. So again, you want that staircase of 1s right here along the diagonal, but this time it's not a 1 already, it's a 3. So I need to get a 1 here. I want this to be a 1. So to get your lead 1s, every time you're getting a lead 1, you're just going to multiply by the reciprocal. So if I want this to become a 1, the reciprocal of 3 is 1/3. So I'm going to multiply row 3 by 1/3. So 1/3, row 3. Everything else stays the same. When you're doing this, you shouldn't do anything else in this same step. So eventually I'm okay with you guys getting the zeros in the same step, and it'll eliminate some of the steps that you have to write out. But never, ever, if you're multiplying a row by something, can you do anything else in that step with it. So the first row stays the same, 1, 0, 11, 23. Second row, 0, 1, 4, 7. And now our last row, 0, 0, 3 times 1/3 is 1, and 6 times 1/3 is 2. Okay, so now, again, we are looking at this column right here, column 3. We have our lead 1. Now I need to get zeros above that. There's nothing below it. So I am going to come up to the top to continue. Draw an arrow to show this. Okay, so now I want to get zeros in those other 2 rows. So here, if you wanted to do them both at the same time, that would be okay. Or you can continue doing them separately. So I'm going to do it separately for this one, just as we since it's our first big one together. All right, so to get a 0, let me actually scroll down for a minute. To get a 0 here, let's do this 11 first. So to get the 11 to become a 0, I need to look at this in this column where my lead 1 is. So my lead 1 is here. I need to multiply that by the additive inverse of 11. So negative 11 times row 3, and add that to the row I want to change, which is row 1. So that means I have negative 11 times row 3. I label it on the row that I'm changing, which is row 1. All right, so here, pause your video and write out this new matrix right here. All right, so you should have multiplied negative 11 times 0 plus 1 is 1. And then it should be 0. And then you have negative 11 times 1 is negative 11 plus 1 would give us a 0. And then in the last one, we have 2 times negative 11, so that'd be negative 22 plus 23 gives you a 1. So everything else stays the same, so 0, 1, 4, 7, and 0, 0, 1, 2. All right, so now we're almost there. We have our lead 1. We have a 0 above it. We need this 4 to become a 0 now. Pause your video here and do the next step on your own, getting that to become a 0. All right, so hopefully for this one, you said to get this 4 to be a 0, I need to add it to a negative 4. So I always multiply the lead 1 by the additive inverse. So I'm going to take negative 4 times row 3 and add it to row 2, because that's the row I want to change is row 2. So my first and last rows will stay the same. The only one that's changing here is going to be row 2. Okay, so we're, hopefully you guys were able to do this one. So you should have had 0, 1, 0, negative 1. So negative 4 times 2 is negative 8 plus 7 gave us negative 1. That's how we got that. Now on this left side of the line, you see we have put this into reduced row echelon form using Gauss-Jordan elimination. So you have the staircase of 1s down the middle diagonal and 0s above and below them. So what this tells me now is that 1x is equal to 1. So x equals 1, y will equal negative 1, and z will equal 2. So as an ordered triple, that would be 1, negative 1, 2 for your final answer. All right, so now let's talk about how to check this in your calculator. So grab your calculator. This one is a little hard for me to see on here. Let me just turn these lights off. So to do this, you're going to go to the matrix button, so second matrix, and you're going to go over to edit. And it asks you for the order, the size of it. So we have, remember, it's rows by columns, R, B, C. So we're going to do 3 rows by 4 columns. And now you're just, after you hit enter, it'll move to the next one. So we're just typing in the original matrix. So 1, negative 2, 3, 9. And then the next one is negative 1, 3, 1, negative 2, and 2, negative 5, 5, 17. Hit second mode to quit. Now we're going to go back into that matrix menu, and we're going to go to math and scroll down to where it says RREF, so choice B. That's reduced row echelon form. You're going to hit enter, then go second matrix again, grab the matrix that you just edited under name, so enter for A, hit enter, and it gives you that matrix. So our calculators can actually solve these systems very, very quickly in 3 variables. Now we see the answer is 1, negative 1, and 2. The calculator will give that to you. Obviously, I'm looking for all of this work to support it, but it's really nice to be able to check those completely in your calculator. So again, that second matrix, edit it first and then use RREF to get the reduced row echelon form. All right, we'll do one more together. So solve using matrices. X plus 2y equals 0, x plus y equals 6, and 3x minus 2y equals 8. So I've got 3 equations, but only 2 variables. So we're going to start by writing these as a matrix. So I've got 1, 2, 0, 1, 1, 6, and 3, negative 2, 8. So just taking the coefficients and setting up my initial matrix. Good news again, we have our lead coefficient of 1. So now I want to work column by column, and I want to get this zeros below that. So for this one, you know what, I'm gonna go down first. I'm gonna try to do it 2 at once. And if that's too much for you, feel free to do 1 at a time, but I'll show you how you can write it with both at one time. So first, let's do the 1. So I want to get this to be a 0, which means I need the additive inverse of 1, which is negative 1. I always multiply the row with the lead 1 by the additive inverse. So negative 1 times row 1 plus the row I want to change, which is row 2. Okay, so pause your video, go through and do just that row, and I'll show you the next one in the same matrix. All right, so that should be 0, negative 2 plus 1 is negative 1, and 0 plus 6 is 6. Okay, the next one, I want to get this 3 to become a 0. So now I'm going to do negative 3 times, always the lead 1 row, and I'm changing row 3, and that's where I label it on the new matrix. Pause your video, go ahead and do that out. So that'll give me 0, negative 8, and positive 8. So now I have my first column done, where I have a lead 1 with the zeros below it. Now I need to get my next lead 1, so along my diagonal, right here. So this one I want to become a positive 1. So in order to get that to be a positive 1, anytime you're trying to get a lead 1, you're going to multiply by the reciprocal, or in this case, we just need to multiply by a negative to get that to become a 1. So our first row stays the same, and then we're going to multiply negative 1 times row 2. So this stays a 0, 1, negative 6. When you're multiplying a row, you're not allowed to do anything else now. And the only time you can do more than one step in a matrix is when you're getting the zeros in the same column. All right, so now I have my lead 1. Now I need to get zeros above and below that. All right, so to do that, I'm going to jump up here. So pause your video and see if you can figure out what you would multiply by to get this 2 to become a 0. Label it and write out that row. All right, so that means we should have done negative 2 times row 2, because that's the row with the lead 1 in it for this column, plus row 1. And my row 2 is going to stay, so that's going to be 0, 1, negative 6. And this one should become now 1, 0, 12. And for the third row, I want to get this negative 8 to become a 0. So I'm going to multiply the row with the lead 1 by positive 8. So 8 times row 2 plus row 3. And that gives me a 0 and a 0, which is okay. And then negative 40. So here's the problem. If this negative 40 had been a 0, then we would be good. X would be 12 and Y would be negative 6. The problem is, in our last row, it's not a full row of zeros. It's 0 equals negative 40, and that is not true, which means if it's false, our system is inconsistent. So again, just a little side note here. If your last row was all zeros, then it would have worked. Okay, but since it was 0 equals negative 40, then it does not work for that one. All right, so again, what I would recommend doing at this point is checking it in your calculator. Really, really important to be checking that in your calculator and getting that inconsistent error for that one. So type in your original matrix right now in your calculator, and then do your RREF under second matrix. So give that a try on your own. And then I'd like you guys to do a couple of practice problems. So the first one is, so we'll call this number 3 then, is x, and then, so no y, minus 3z equals -5, 3x plus y minus 2z equals -4. Now, when you're setting up your matrix for this one, because there's nothing in here for the y, your original matrix, you just put in a 0 for that. So it would be 1, 0, -3, -5 for that first equation. Okay, so pause your video, solve this, and then I want you guys to use Gauss-Jordan, so get it in reduced row echelon form just like we did before, and check that answer in your calculator. All right, so I'll go over one more time how to check it in your calculator. And here you're going to go to second matrix, which is your x to the negative first. Go over to edit. So if I want to edit this right on top of it, I'm just going to type over it. So 3 by 4 is still a 3 by 4. So this is going to be 1, 0, -3, -5, and then 3, 1, -2, -4, and 2, 2, 1, -2. Hit second quit, second mode, and then go back to the second matrix menu, hit math, so over to the right one, down to RREF, which is choice B, and then back to second matrix again so that you can grab letter A and then hit enter. So your final answer on this one should be 1, -3, 2. And you should have checked that in your calculator on your own. Make sure you know how to do that for number 1 there, or for number 3. Okay, and then number 4, we'll do one more. X plus 2y plus 6z equals 1. 2x plus 5y plus 15z equals 4. And 3x plus y plus 3z equals -6. So use matrices and Gauss-Jordan elimination to solve that. Remember, go column by column. So get your lead 1, which we already have one there first, then get your zeros below it, and then go to column 2 after that. Once you finish this one, go ahead and check it in your calculator. Again, to check this one in your calculator, you're going to second matrix, over to edit. It's again a 3 by 4. This one's 1, 2, 6, 1, and 2, 5, 15, 4, and 3, 1, 3, -6. And then we're going to do second matrix, math, down to RREF, which is choice B. And then second matrix again, grab the one we just filled in, and then we hit enter for this one. Now, you'll see it actually doesn't say error to you, but you can look at this and know that your bottom row is not all zeros. It's 0, 0, 0, 1. And we know 0 is not equal to 1, so that's what tells us that this system would be inconsistent. Okay, so really important that you understand how that looks when you do check that in your calculator. All right, and make sure you can do all those on your own and check them in your calculator on your own. You need to practice that to get better at it and to remember all the steps. I know these are hard, they are long, and you have to be really careful and meticulous as you do them, and you must do the same process that I've showed you every single time. So work column by column, get your lead 1, then get the zeros below. Then go to column 2, get your lead 1, get zeros above and below for that one. Okay, and if you have any questions at all, of course you can come and see me or set up a meet. Let me know if you need anything. And I hope this was fun because I think these are pretty cool. Even though they're long, they are really fun to do. They're used a lot with coding, which is kind of neat. But again, let me know if there's anything you need, if you need any help on these. Have a great day and pie out.